Assalamualaikum warahmatullahi wabarakatuh to the panel. My name is AMIRULFIKRI bin Muhammad Kalil, student semester 7 in Mechanical Engineering at UiTM Shah Alam. Today I want to present to you about my proposal for my final year project 1. The title of the project is CFD Simulation of Separation of COVID-19 Virus in Enclosed Building in terms of various social distancing. My supervisor's name is Dr. Muhammad Faizal bin Muhammad. This is my content of my proposal, which is project summary, introduction, problem statement, objective, scope and limitation, literature review, methodology, expected result and reference. Project summary. Computation Fluid Dynamics or CFD is a branch of engineering analysis that focus of analyzing the problem that influence in fluid flow. CFD is a science of predicting fluid flow, heat transfer and mass transfer by solving mathematical principles that govern this process. Overall, my final project is run CFD simulation in an enclosed building with include the occupant with COVID-19. Then we will see and predict the separation of COVID-19 virus. Introduction. COVID-19 was triggered by the new type of coronavirus, which is SARS-2. This virus was declared as a pandemic disease. Because of that, the government of each country come up with a recovery plan. Some of the plan is lockdown, mass vaccination, and social distancing. This project will focus on social distancing. Social distancing is a long-term viable solution to cut the chain of separation of COVID-19 virus. Based on Center of Disease Control (CDC) and National Health Service (NHS), the recommended distance is 2 meter while World Health Organization or WHO state 1 meter is enough. This recommended distance was based on the respiratory droplet fallout. It is depends on the way of ejected droplet fallout from respiratory mechanism, either normal talk, coughing or sneezing. To run the simulation, two persons will standing between each other with different distance and different respiratory mechanism for ejected the flow. Problem statement. For the past 2 years of pandemic COVID-19, we can see the trend of increasing in the existence of cluster of COVID-19, mostly from workplace and enclosed building, for example, Top Glove and 2020 Tablighi Jamaat. Both of these clusters are related to enclosed building, which is factory and mosque. Thus, this project aims to better understand on how the virus can separate in enclosed building. From this problem statement, two research questions can be generated. First, how the flow pattern of CoV-SARS-2 can be modified based on different occupant position. And two, dispersion of the CoV-SARS-2 in terms of number of concentration in different respiratory mechanism. Objective. From the research question generated at the problem statement, two objectives can be met, which is first to evaluate the flow pattern within the building envelope in enclosed building. Second, to investigate the dispersion of virus and include the occupant with SARS-2 in an office with different social distance. Scope and limitation. Scope of this study is focused on separation of COVID-19 virus through airborne. The limitation is separation through direct contact, such as touching, will not be covered. There are selected variables that will be used in the simulation. The limitation of the variable is based on the setup of WHO and CDC as I said earlier, which is 1 meter and 2 meter for the social distance. Next scope of the simulation is focused on the separation in an enclosed building. Separation in an open building will not be covered because it is the limitation of this project. Literature review. Chan Duan-sun 2020 said in the literature there are a few studies that look at droplet transmission trajectories through human respiratory action such as talking, eating, coughing and sneezing. Next, Naoya Ito mentioned they should be kept in a separate, well-ventilated room about 2 meters from other patients with easy access to respiratory hygiene equipment. Next, Mariam 2020 conclude in her analysis by saying normal talking event is the lowest release velocity and particle number of concentration of the respiratory. However, even after 30 minutes after the event, the particle remain at the receptor site, demonstrating the danger of staying in close surrounding with asymptomatic people for lengthy period of time. Next is J. Kalir 2020 said, according to the CDC, the coronavirus spread through respiratory droplet that becomes airborne when an infected person talks, sneezes, or coughs. John Brunner 2020 state that a model of respiratory droplet and aerosol distribution by Lagrangian turbulent airflow is constructed and used to demonstrate how the SARS-CoV-2 coronavirus can be distributed by an infected person breathing. In the strategic location where the air recirculates, the concentration of virus in the exhale cloud can increase to infectious level of over time, which is grow linearly. Methodology. In this project, the configuration of the office area is dimension of 4 times 4 times 3 meter. It is a cuboidal box with coordinate x equal to 0, y equal to 0, z equal to 0, to x equal to 4, y equal to 4, z equal to 3. In terms of setup of the simulation, two human model will be placed within the room with two variable setup, 1 meter and 2 meter. The placement of inlet and outlet is fixed at the ceiling. The run step standard K epsilon turbulence model will be used to close all the simulation in the study. And the flow of the study is a steady state flow. Source of the simulation is from the mouth of the emitter who is produced virus carrying respiratory droplet during a variety of events which is normal talk and coughing. Expected result. Based on the figure 1, coughing will produce more number of concentration than normal talk. Figure 2 shows that across the time, the number of concentration is higher in coughing rather than normal talk. We can see the red line and green line at the graph of figure 2. However, the longer the time of simulation, it can be said that normal talk can separate more than coughing. This is because coughing will produce a droplet which is heavier, while normal talk produce aerosol particle which is lighter and can hold more at the thin air. These are the references that I used while completing my proposal. That's all from me. Thank you.